Hello everyone, today we will talk about a very common mistake which a lot of new developers do around the usage of interfaces. So what I have observed that over a period of time, more and more developers are moving to the microservices development. Every organization is writing microservices, okay? And code bases are becoming small, and with that what is happening that people are losing the programming skills. They are not using all those good practices because now they do not have bigger code bases to maintain. Microservices with its own small code base and no need to manage a lot of complexities in it, right? So that's why people are losing a bit of a skill around usage of OOPs. I'm not saying that everyone is losing it, but in general I am seeing that the smaller code bases do not have all those different rich examples of usage of design patterns or good practices. Solid principles are missing, and the problem with that is not knowing the design patterns is not the problem, but it gives you a thinking construct. With time it gives you an ability to think. When you think about solid principles or good practices, or when you solve a problem writing the code, and that's all, it strengthens your memory. So that's what is happening. And another thing, of course, code bases are suffering. Lot of organizations, they are merging their microservices back because of so many issues, but when they want to merge back again, the code bases are becoming huge, and then they realize that okay, in the absence of good interfaces is just one thing, and basically good usage of OOPs principles, they are having a lot of troubles. So in this example I will focus on very specific thing, and especially on the Java interfaces, and in the Spring Boot. This is a simple example. I'll try to show how it is having that problem. So here it is a very simple class, and it have a payment processor inside it, right? And if I show you the payment processor class, just for example, I have kept it very simple, right? It have a process method, and order is a plain simple Pojo. So is there anything wrong in this class, or okay, in this class, is there something wrong in it? Okay. So many of you might say that okay, instead of auto wiring we should use constructor, because constructor helps us testing things easily. Okay, so even if I add an constructor here, okay, it's the order service, so let's add order service constructor this way and make it accept from payment processor, and this dot payment processor is to remove this auto wiring, and okay, make it public, put an annotation or not, Spring will take care of auto wiring. Okay, so is there any other problem now? Yes, there is one problem. What if you want to inject a different payment processor? So if I show you this payment processor, this is a concrete class, right? If you want to change the implementation of payment processor, is it possible here? No, right? Why? Because this is a concrete class, you have not injected the interface here, right? So if you see, this class is not open for extension. Is there any way you can use abstraction or something like that, so that can you change the bean, right? In the existing case, no. Imagine a situation when you want to use a different payment processor, for example PayPal payment processor or credit card payment processor. What is the option you have left? Either you will end up adding a lot of code inside the payment processor itself and then using the if else to figure out, but yes, you cannot inject the different bean here. So that's the one problem. Second problem here is testability issues. How testability issues? Okay, I'll explain. Let's say you and your fellow programmer are given the responsibility to implement the order service, and now you guys want to divide the work. So you say that, okay, I will work on this class order service. It's just for an example. It might be another complex class depending upon another object. So here you have composed your order service with payment processor, right? So is it possible for you to work on this class until unless you get the implementation of payment processor class? No, it will be not easy. You need to coordinate a lot, and it could have been very easy if your fellow programmer just create the payment processor interface, write methods in it, and that's it, and just commit it. So interface without any implementation, even if you push into the repo, it will not break anything, and you can use it. And how it will help you in writing unit test cases, because when you will be unit testing order service class, you will be using mock for this, right? So now you have a class, you can do the mock, you have a class or interface, you can do the mocking of that. But in absence of interface, you need to wait for the actual class to be, compiled and in place, right? So you can still test it, but it's a little messy to test two classes working together, right? So having interfaces can make things easy. At day one, your fellow programmer can give you just the interface, and rest of the things will work fine. Third problem here is reduced extensibility, right? Extensibility in the sense, of course, we talked about the point that if you want to inject another bean here, or imagine a situation when you want to use more than one processor, right? And more than one processor, I mean at the same time for one order you need let's say PayPal processor, another you need credit card payment processor, and depending upon the flow you need to decide which bean to use, right? So that is not possible when you have such type of logic, right? So solution is very simple, and the root cause of the problem was also very simple. So here in another code, I have shown the simple example here, the one with the right code. So instead of hard-coded class or the concrete class, hard-coded is not the right word, I have introduced an interface, very simple interface, payment processor, just a process method. So I am focusing only on the usage of interface, right? Imagine now you want to write the test cases of your class. So your fellow developer will just give you this interface, commit it, and you can start testing, right? I will show you your order service test. You just mock it, and that's it, right? You have at least a compilable class which you can mock or inject or whatever you do. But imagine your fellow developer is writing payment processor class and still it's in progress. So that's a challenge, right? Code might keep on breaking if we keep on committing or she can keep on committing the changes in it. So that's one thing it has solved. Another thing is now I can have different implementations of payment processor. For example, credit card payment processor is one implementation, and you observe that there is a profile annotation I have put on it. It's not necessary to have it, but I'll show you why I put the annotation. So this profile annotation is here in place. Another is PayPal payment processor. I have put another profile. Okay. So now imagine your application is up and running. It needs to run, and your application is supposed to do all the transactions just with this particular microservice instance needs to work just with the credit card payment processor. Okay, it do not need PayPal payment processor. Only one implementation of this interface is needed. So it's very easy to handle using the profiles. Okay, you just activate the required profiles, credit card in this case. So when your application will run, it will get this implementation, credit card payment processor, as an implementation of this interface, right? So that's one benefit. Now you might say that I might need both the implementations, right, in a running transaction, or in two different transactions. For one I might need credit card, I might need PayPal for another. Okay, so in that case I will not show you the detailed example, but I will give you some hint. One approach here is you can use payment processor factory. Okay, I'll just show it a bit detailed here. So in payment processor factory there is a simple map of all the implementations of iPayment processors, right? I can hold it in a map because it's an interface, and that's how it will help. And this is a simple class here with the application context. You get all the beans and just add them as the key value pairs, right? And there is a method get processor which will give you the right type of bean from this, right? If you go back to the order service class, okay, here if you instead of iPayment processor, now you just payment processor factory, you call it factory just to keep it short, and then you can call the method factory.getProcessor. Okay, what type? Payment type, of course you will need. So when you are placing an order, you know by which mechanism your user is trying to do the payment. So let's say you need to pass the payment type here, and it will give you the process and order. Okay, from where you will get the order, payment type maybe as an separate argument here. Okay, payment type maybe, or something else. Okay, but the whole idea was here is to show that in case you want different type of processors depending upon the flow, this is one way of handling it. Okay, I'll just remove this. I'll show you something else also. Okay, so now if you see another simple class, payment processor resolver. Okay, so this is a lookup bean provided by Spring. I'll show you here. Okay, Spring bean factory annotation lookup. This class is marked as component. It's an abstract. Okay, so I'll not go inside depth of the lookup, but if you see somehow Spring is able to inject the implementation of it, and that what that implementation do, when you call this method, it returns you a bean with this name, right? And credit card payment processor. Okay, so this bean will be, of course, when there is nothing done explicitly, its name will be credit card payment processor in the camel case, the way it is mentioned here. Okay, and what this get PayPal processor do, it will return you the PayPal payment processor bean. Okay, so now if I go back to your order service class, here again it's instead of introducing factory, now just to demonstrate, I'll need payment processor resolver. Okay, so let's call it resolver just to keep it simple. And if you do the resolver dot get PayPal processor or process order, okay, and that's one thing you can do. Or if I'll show you this class, payment process resolver, not this one but here. Okay, so maybe you can simply add a method here, resolver. Okay, get resolver, and okay, I have a sample implementation here. Let me copy it for you and show it to you. Okay, okay, so it should be iPayment processor now, and that's how, right? So here you should do the resolve processor, and you should pass the payment type, whatever it is, credit card or PayPal. It need to be match here. So switch case, right? No if else, so that it do not bring in complexity in future, and you just pass order here, right? So that's how you can inject different logic also, and in this case you will not need these, auto wire it or put it inside the constructor. So idea is, when you bring in the interfaces in place, right, or right, payment processor interfaces you have brought in place, and what is the advantage? Your code is much cleaner, nicer, and a bit generic, right? So now inside your process resolver you just need to manage what type of resolver you will get, and better is that your payment this resolver method, instead of here, how about if we put it here, okay, and resolver, okay, so you will need maybe instead of this you should do this dot get, right? I'm just writing the simple code, not handling lot of case scenarios, just trying to show you that when you introduce the interfaces, it opens up lot of possibility, right? Okay, that method must be private. Okay, open it, make it public, okay, and resolve processor, whatever the type payment you pass, and then okay, process order. Okay, so this class is very simple. Your payment process resolver will have all the complexities. It's nicer, cleaner, and why it is possible? Because here for the processing payment processors you have introduced the interfaces, okay, and it will be really good if you introduce an interface for payment process resolver also, okay. So this is a simple class. You can introduce an interface and you can provide the default implementation of that, or it's really nice and clean if instead of using the hard-coded classes you use the interfaces in general, okay. So usage of interfaces makes the classes nicer, cleaner, and opens up a lot of possibility of using the solid principles, right? So I have committed this code in the repo. I'll put the link in description if you want to take a look, and feel free to leave your comments or questions or anything, and thank you so much. Bye.